we're going to look at graphing sine and cosine. You can always plug in the radian value and come up with the associated y value on your graph. But what I want to do is point out the patterns that can be used to graph sine and cosine. For y equals cosine x, we'll add the shape in just a second. The amplitude for this is 1. Remember, amplitude is half the height of a wave, and we get that from the 1 that we assume is right there in front of cosine. The period for cosine is 2 pi. When I put this on my graph, cosine, my pattern for cosine, it starts at a maximum at the amplitude of 1. It has a maximum at the end of its period at 2 pi. Exactly halfway between those two is a minimum, and halfway between the maximum and the minimum is a 0. And if I were to connect those as best I can, there we go. When I talk about the shape of my cosine graph, I talk about it as maximum to maximum. Let's look at sine. The amplitude is 1, again for the same reason, a coefficient of 1, and the period here is 2 pi. For sine, sine starts at 0. It has a 0 at the end of its period at 2 pi, and a 0 halfway in between. Halfway between the first two zeros is a maximum. Halfway between the second two zeros is a minimum. And again, I can draw that in. And when I talk about my shape of sine, it looks kind of like that. Just knowing these things will help us graph any variation of our sine and cosine functions. Let's look at what happens when we have an a value out front. This number is going to do two things. The a value is the amplitude. That's going to tell us where our maximum and minimum, how high up and how low down they go. But the amplitude will always be positive because it is half the height of a wave. If we have a situation where we have a negative value, that means we are going to flip our picture. Let's see what that looks like. Y equals 2 sine x. Sine has the shape up to down. The amplitude is this 2, and nothing is changing the period. The period is 2 pi. We'll get to changes in period in a minute. To graph it, sine starts at 0. It has a 0 at the end of its period, which is 2 pi. Halfway between, it has a 0. Halfway between my first two zeros is a maximum. The amplitude is 2, so up 2. Halfway between my other two zeros is a minimum, down 2. In using this pattern, we're not trying to plot anything. We're just using the pattern. For y equals negative 3 cosine x, my shape for cosine is maximum to maximum, but we have a negative, so we will have to flip this, and it will now be minimum to minimum. My amplitude comes from that number. It is 3. The amplitude is not negative 3. It's just 3. And my period is 2 pi. To graph, cosine usually starts at a maximum, but we flipped it. It's going to start at a minimum, which will be down 3 because that's the amplitude. We'll have another minimum at the end of our period, which is 2 pi. Exactly halfway between, we will have a maximum, which will be up 3. And halfway between those, we have zeros. Let's look at another type of situation. Here, we have plus or minus d. Plus or minus d results in a vertical shift. We are going to move up if it's positive, down if it's negative. I know that seems kind of common sense, but we'll have some issues later where that's not true. When I graph these, I graph the D, this vertical shift, as a new x-axis. And although my new x-axis is kind of a fake axis because my x-axis doesn't really move, it will help us with our graphing. Here we have the cosine of x minus 3. My shape, cosine is maximum to maximum. My amplitude is 1 because there is no coefficient to cosine. My period is 2 pi. And my vertical shift is minus 3, so down 3. The first thing I'll put on my graph is my vertical shift. I'm going to have a new x-axis down 3. Now, when I talk about intercepts through my pattern, I mean on my new x-axis, not the real x-axis. Cosine starts at a maximum. We have an amplitude of 1, so from our new x-axis, up 1 will be our maximum. We have another maximum at the end of our period, which is 2 pi. Halfway between we have a minimum, and halfway between we have zeros. Again, those zeros are on our fake x-axis, not the real x-axis. There we are. Negative sine x plus 2. So sine is up to down, but it is negative right there. So that means we have to flip. Now we'll go down to up. My amplitude is 1. My period is 2 pi. My vertical shift, positive 2, up 2. To start, new y-axis up 2. Next, sine starts at a 0. It has another 0 at the end of its period and a 0 halfway between. Halfway between my first two zeros is usually a maximum, but we flipped it, so now it's a minimum, and my amplitude is 1, so the minimum is down 1. And then halfway between my last two zeros, I have a maximum up 1. Let's look at a different situation. Here, we have a b value. That is going to affect our period. The period, I abbreviate PD, will be 2 pi over b. So we may have to do a little math to figure out what the period is. Sine of 3/4 x. The shape for sine, up to down. My amplitude here is 1. There's no coefficient of sine. Now for the period, we will have 2 pi divided by 3/4, which is the same thing as 2 pi times 4/3, which is 8 pi over 3. With problems like this, we'll need to look at how we should label our axis. If 2 pi is, If our period is 8 pi over 3, why don't we make each box pi over 3 so that 8 of them will get us our entire period? So pi over 3, 2, 3, 4, 5, 6, 7, 8 pi over 3. And that's really all I need to do. Now I'm ready to graph. Sine starts at 0. It has a 0 at the end of its period, which in this case is 8 pi over 3, which is 8 boxes. Halfway between those, I have another 0. Halfway between my first two zeros, I have a maximum up the amplitude of 1, and then a minimum. The hardest part of those is figuring out your scale. Y equals negative cosine of 3x. My shape, cosine is maximum to maximum, but we have this negative out front, so we have to flip it, so it will be minimum to minimum. My amplitude is 1. Now I use the b value to find my period, and the period will be 2 pi over 3. To look at how I want my scale to go, if I make one box pi over 3, then two boxes would be 2 pi over 3, and everything is going to be, everything's going to be really squished. So let's make it a little bit wider than that. Let's let two boxes be pi over 3. So then 4 boxes would be 2 pi over 3. And that'll let us get it done. Cosine usually starts with a maximum, but we flipped it, so it's going to start with a minimum at the amplitude of 1. It has another minimum at the end of its period, halfway between a maximum and halfway between our zeros. I'm sorry, you hear one of my children is texting me if you hear the mom, mom, mummy. Now we have yet another situation, although this time we're combining two situations. So the A value will be my amplitude, and the B's will affect my period. And the period is still 2 pi over b. The shape for sine is maximum to minimum, right? The amplitude in this problem is the 2. For the period, we would be looking at 2 pi divided by 2/3, which is 2 pi times 3/2. So 3 pi. Now we need to look at what we might want our scale to be. It looks like we can do 4 boxes as pi. So then 8 boxes would be 2 pi, and 12 boxes would be 3 pi. Now I'm ready to graph. Sine starts at a 0. It has a 0 at the end of its period, which is 3 pi. Exactly halfway between, which would be 6 boxes, is a 0. Halfway between my first two zeros is a maximum, which will be at 2 because that's my amplitude. And then halfway between, didn't put that halfway. There we go. It should be at 3 boxes over. And then 3 boxes over here is a minimum. It's so nice once you know that pattern, you can graph any of them. Here, sine is maximum to minimum, but we have a negative, which means we have to flip, which means sine will be minimum to maximum. The amplitude is 1/2, so it's going to be squished up. The period will be 2 pi over pi, which is 2. First, let's think about how we might want to do our boxes. Let's do 4 boxes as 1 so we can see what's happening. If you make it too small, you won't be able to see what's going on. Now I'm ready to graph. Sine starts at 0. It has a 0 at the end of its period, which is 2. Halfway between, it has another 0. Halfway between my first 2 zeros, we usually have a maximum, but we flipped it so we have a minimum, and it's at 1/2. And then halfway between my last 2 zeros, I have a maximum. Another situation. Something new and interesting. Here, we now have a C value, plus or minus C. This is going to result in a horizontal shift, but it will go in the opposite direction of the sign. So if it's positive, we will move left. If it's negative, we will move right. Sorry, I drew left, didn't I? There we go. Graphically, I make this a new y-axis. And then we treat our new y-axis as our new 0. Again, it's fake. It's not the real y-axis, but it will help us graph. First, the shape, sine, maximum to minimum. The amplitude is 5/2, which is 2.5. There is nothing impacting the period here, so it's 2 pi. And our horizontal shift, this is a minus pi, so it will be right pi. Just like the last type we did, now we need to pay attention to what our scale might be. We have a period of 2 pi and we're moving right pi. So let's let 4 boxes be pi. Now, we will start by graphing our new y-axis, which is right pi. There's my new y-axis. Now I'm ready to graph. Sine starts at 0, so that's the 0 of my new y-axis. We have a 0 at the end of our period, which is 2 pi away. We have a 0 halfway between. Halfway between is a maximum, so up 2.5. Halfway between is a minimum, so down 2.5. As long as you have the pattern, you're good. Here we have a cosine. The shape for cosine is maximum to maximum, but we have this -3. We have to flip, so now we are minimum to minimum. The amplitude is 3. The period is 2 pi. And my horizontal shift plus 3 pi over 2. So left 3 pi over 2. Now we need to think about what we want to do with our boxes. We need to move left 3 pi over 2. What if we make 2 boxes pi over 2? I'm going to write that. 2 boxes is pi over 2. So 4 boxes would be pi, and 8 boxes would be 2 pi. And then over here we'll make that negative pi over 2, just so we remember. Now we'll put in our new y-axis, moving left 3 pi over 2. 2 boxes is pi over 2, so 4 would be 2 pi over 2, and 6 would be 3 pi over 2. Now we're ready to graph cosine. It usually starts at a maximum. We flipped it. It starts at a minimum, down 3 because of the amplitude. Then we need another minimum at the end of our period, which is 2 pi, which is 8 boxes away. So this was 1, 2, 3, 4, 5, 6, 7, 8 boxes. There we are. Halfway between there, so at 4 boxes, we'll have a maximum. And then halfway between, we have zeros. Oh, I didn't do that very well at all. Let's try again. Okay. Last situation, ladies and gentlemen, I think. Here, we're still going to have our A, which is going to impact our amplitude. We're still going to have the B, which is the period. But C is where things will be a little bit different. Now, this still is our horizontal shift, but our shift is actually to find the amount of our shift. It will be C over B. Think about it as factoring out the B. If I had BX, if I had BX plus or minus C, I've got to factor this B out and pull it out front to know what that shift will be. Okay? Here. The shape is cosine, maximum to maximum. The amplitude is 2. There it is. The period comes from this 3/2. 2 pi divided by 3/2, which is 2 pi times 2/3, which is 4 pi over 3. For my horizontal shift, here's my negative pi over 4. We know it's going to move right, but the amount is going to be pi over 4 divided by 3/2, B over C. C over B, which is pi over 4 times 2/3, which is pi over 6. Now we want to look at how we want to do our graph. I would say that we make one box be pi over 6. So there's pi over 6, which means that 2 boxes is pi over 3. So 6 boxes would be pi, right? Pi over 6. 1, 2, 3, 4, 5, 6. Here's pi. And then 2, 3, 4, 5, 6. There's 2 pi. And then we'll go ahead and go over here and make a negative pi over 6. So let's look at graphing. We are moving right, pi over 6, so we are just making a new y-axis right there. Cosine starts at the maximum, which is up 2 on my new y-axis. Now, I need another maximum at the end of my period, which is 4 pi over 3. If 2 boxes is pi over 3, then 8 boxes would be 4 pi over 3. So I need to go over 8. 1, 2, 3, 4, 5, 6, 7, 8. And then halfway between those is a minimum, down 2. And halfway between those are zeros. 2 more. The shape, this is sine, so maximum to minimum, but we have a negative, which means we have to flip it. So it is minimum to maximum. My amplitude is 3. My period will be 2 pi divided by 3/4, 2 pi over b, which is 2 pi times 4/3, which is 8 pi over 3. My horizontal shift is negative, so that means I am moving to the right. To find the amount, I do c over b. So pi over 2 divided by 3/4, which is pi over 2 times 4/3, which is 2 pi over 3. Now here, when I look at my scale, what I would do is probably pi over 3 for a box, because both my period and my horizontal shift are over 3s. So we'll make pi over 3 one box. So there's pi over 3, and we can really just leave that. Next, my new y-axis, we're moving right 2 pi over 3, so 2 boxes. To graph sine, we start with a 0. We have a 0 at the end of our period, which is 8 pi over 3, which will be 8 boxes away. 4, 5, 6, 7, 8. Halfway between is another 0. Halfway between my first two zeros is usually a maximum, but we flipped it over, so it's a minimum, and I'm going down 3 because that was my amplitude. And then halfway between my other two zeros is a maximum. Last one. Oh, I'm sorry, I lied. Last kind here, sorry. So here we have our A value will be our amplitude. Our B value will be our period, well, 2 pi over B. And then we're bringing back our vertical shift. So we're just doing all of those things at once. Now, we have 3 examples and we're done with graphing sine and cosine. First, cosine maximum to maximum. The amplitude here is 3. The period comes from the coefficient of x, 2 pi over 2, which is pi. My vertical shift is the -1, so down 1. This graph doesn't have an axis on it, so let's make 4 boxes pi. 8 boxes is 2 pi. Next, we need to put in our vertical shift, down 1. Then we're ready to graph. Cosine starts at a maximum. My amplitude is 3, so I'm going to go up 3 from my new x-axis. We have another maximum at the end of our period. Halfway between a minimum, and that minimum is down 3 from my new axis. And then halfway between those are zeros, and again, those zeros are on my new x-axis, not the real one. Here, cosine, maximum to maximum, but we have a negative, so we got to flip it over, minimum to minimum. The amplitude here is 2. The period, 2 pi divided by 2/3, which is 2 pi times 3 over 2, which is 3 pi. And my vertical shift, -2, so down 2. We'll put an axis on, 3 pi. Let's go ahead and make 4 boxes equal to pi. So pi, 2 pi, 3 pi. Then my vertical shift, down 2. Now to graph. Cosine usually starts with a maximum. We flipped it. It starts with a minimum, and I'll go down 2 from my new y-axis, x-axis. We have another minimum at the end of our period, which is 3 pi. Halfway between there, we have a maximum, which is 2 units from our new y-axis, x-axis. I don't know why I keep saying that. And then halfway between those, we have zeros. Last example. Here, my shape will be maximum to minimum, right? My amplitude is 3/2, which is 1.5. The period will be 2 pi divided by 3/2, which is 2 pi times 2/3, so 4 pi over 3. And my vertical shift, +1, up 1. Looking at my units, I would say let's make 2 boxes pi over 3 so we get it to be big enough. So 2 pi over 3, 3 pi over 3, 4 pi over 3. Next, doing my vertical shift, up 1, that's my new x-axis. Then I'm ready to graph. Sine starts with a 0, has a 0 at the end of its period. Halfway between has another 0. Halfway between there is a maximum, which is up 1.5 from my new x-axis. And halfway between the other 2 zeros is a minimum. I hope you found this helpful and you understand the pattern. This will also help you graph tangent, cotangent, secant, and cosecant. Good luck.